the probability of observing a test statistic of a given magnitude or larger if the null hypothesis is true. That's our p-value. And now we have to decide, is it statistically significant or not? And we have to think, we have to agree upon some rules of this game. What is weird? What is going to be a strange enough value to say, hey, let me reject that null hypothesis? You probably heard, is p less than 0.05? 0.05 is chosen as sort of this yardstick or this line in the sand of where we say, hey, that is now statistical significance. But that's arbitrary. You could choose any value that you want. When you choose that value, it's called the alpha level. It's the criterion that you choose for statistical significance. We're going to see that you can dial this a little tighter or a little looser, depending if you want to make it harder or easier to find statistical significance. This is a little bit weird for some students because most of us think, hey, that's significant. Hey, that's not. But we have a little bit of control over some of this. What's important here is that I used to have a quiz question that went something like this. I said, I put 6 blanks like this: 1, 2, 3, 4, 5, 6. And I would say, use the letters T, alpha, and P, and then come up with 3 verbs and fill in these 6 blanks. And then I would say, how do you run a t-test? And so people would say, well, first I need to set alpha. And then I need to calculate t. And then I need to determine p. And then once I have that p-value, I can go back and I can evaluate that p-value relative to alpha. If p is less than alpha, we reject the null. We state statistically significant. We get to put a little asterisk next to it. Maybe we'll get published. We get to keep our jobs. It's good. If p is greater than 0.05, now do not ever say we accept the null hypothesis. You never accept it. You only fail to reject it. This is really important. Remember, absence of evidence is not evidence of absence. So this is what we do. Once we calculate our test statistic, we sort of convert it into a p-value, like the currency of statistics. And then we look at our p-value and we say, is it weird or not? Well, what's your standard for weirdness? Usually it's 0.05. This raises the really interesting question of why 0.05? There's a great article by Jerry Delal in the Little Handbook of Statistical Practice, and he argues that 0.05, it works. There's nothing magical about it. Moses didn't come down with some tablets and one of them said alpha should be 0.05. No, it's just strict enough that a lot of garbage doesn't get into the literature, but it's relaxed enough that we can still publish stuff. If it were tighter, there would be fewer things that we discovered. If it were looser, there would just be more crap that had gotten in. So it's sort of evolved over time of, hey, it seems to work. And you can argue whether that's true or not. I have a book, I was just reading this, 7 Pillars of Statistical Wisdom, and they talk about some examples of when you would use a different alpha level. And they were talking about the Higgs boson. And for the Higgs boson, the alpha level was 0.0000000, 12 O's, 1. Because they wanted to make sure that if there was something there that was significant, that they would catch it. And sorry, I said that wrong. They wanted to make sure that they wouldn't declare significance if there really wasn't anything there. We'll come back to that when we talk about the idea of alpha and beta error. Now, we can think about statistical significance in 2 ways. You can either judge statistical significance by p-values and look at it relative to the alpha level, or you can judge statistical significance by confidence intervals and look to see if the null value is in there. So these 2 things should tell you the same. If the p-value is less than 0.05, we reject the null, and whatever that corresponding confidence interval will be, it does not include the null value. If the p-value is greater than 0.05, There's no evidence that anything's going on. We fail to reject the null. And that confidence interval will then include the null value. So you can go back and look at some of the confidence intervals we did, either for means, proportions, differences in means, and you can use those CIs to assess statistical significance. So it's really important to understand the relationship between the p-value and the confidence interval.